Welcome to Ask and Learn.
Looking down the C2-C3 bond of pentane, if we were to draw Newman projections, the front carbon would have a methyl and two hydrogens attached. The back carbon would have two hydrogens and an ethyl. So remember the circle and the point at the center of the circle are two carbons. The methyl pointed up will be a third carbon, and then the ethyl pointed down will be carbons 4 and 5. So that's the staggered anti-conformation. As we rotate 60 degrees, we get an eclipse conformation. Then rotate another 60 degrees. Get staggered gauche, where the methyl and the ethyl are 60 degrees apart from each other. Then rotating another 60 degrees, we will get a conformation where the methyl and the ethyl eclipse each other. Then continuing to rotate 60 degrees, we will generate the mirror image conformations. And staggered gauche. Then eclipsed. And another 60 degrees would take us back to staggered anti. So the energy diagram would have a minimum for the staggered anti, a local maximum for the first eclipsed, then a local minimum for the staggered gauche at 180 degrees, or sorry, at 120 degrees. At 180 degrees will be the highest energy eclipsed. And then the staggered gauche at 240 degrees will have the same energy as the one at 120 degrees. The eclipsed at 300 will have the same energy as the one at 60. And then at 360, we're back to the staggered anti. Okay, now 3-methyl pentane. It's going to be a little bit different. We're still looking down the C2, C3 bond, so carbon 2 has a methyl and 2 hydrogens attached to it. But the back carbons are going to have an ethyl and a hydrogen and a methyl. And when we rotate 60 degrees, we get an eclipsed conformation. Rotate 60 degrees, we will get another staggered conformation. And rotate 60 degrees. We will get eclipsed, where the front methyl is eclipsing the back ethyl. And now we proceed to continue rotating. Get staggered. Then rotate 60 degrees to get eclipsed. And then if we rotated another 60 degrees, we would get back to the original conformation that we started with. So now for the energy diagram. What we have to look at are the interactions within the Newman projections, and in particular looking at the staggered conformations to see where we have gauche interactions and what those are between. So in the first structure we started with, the Gauche interaction is between two methyls. And then the second staggered structure at 120 degrees has gauche interactions between both methyls and a methyl and an ethyl. The 180 degree one would appear to probably have the greatest energy because of the eclipsing of the front methyl with the back ethyl. And by inspection, we don't really have any conformations that are truly identical to each other, although the ethyl can arrange itself in a way that it's really the CH2 of the ethyl that's being eclipsed. So in some ways, we can think of it as being the same size as the methyl. So then the question is, what is eclipsing what? But the staggered conformations will have energy minima. The eclipsed will have energy maxima. And the highest energy staggered conformation will be at the 120 degrees. The 0 and 240 degrees should be somewhat similar. And then in terms of the eclipsed structures, the eclipsing interactions at 60 degrees and 180 degrees should be somewhat similar. The eclipsing at 300 degrees should be a little bit lower in energy, given that we have a carbon eclipsing a hydrogen at all three spot, or hydrogen eclipsing carbon, and no carbons eclipsing carbons. So our energy from 0 degrees to 100 to 60 will increase. Will decrease some going to 120, but not come all the way back down. Then the energy at 180 should be similar to what we saw at 60. $240 should be similar to our initial energy, because there's one gauche interaction. And at 300 degrees, it will be a maximum, but local maximum, not a global maximum. And then, of course, as we get to 360, we'll be back to the original energy level.